Okay, ma. Good afternoon. So last class we studied what? Haloalkane and haloarene. Yeah. So we completed the IPS name and preparations of haloalkane. Then some properties also we studied, isn't it? I think 2 properties we studied, isn't it? Okay. Now we are going to study about again haloalkane, some chemical properties remaining. I think 2 properties are important properties remaining. Okay. So you put it. Now third one. Third one is that just right. Nucleophilic substitution reaction. Nucleophilic substitution reaction. Okay. Here nucleophilic substitution reaction means mostly, aqueous KOH are used, no? Aqueous KOH. Aqueous KOH. Last class we studied alkyl KOH, no? So here nothing but the basic difference is, alkyl KOH means here it's a strong base. Okay. Here when compared to here aqueous KOH means somewhat weak base. That's the main difference. Okay. So strong base means what? It can easy to absorb or easy to abstract proton. Okay, that's the main difference between alkyl KOH and aqueous KOH. Understood? Last class I told then suppose what you studied, CH3CH2, Br, alcoholic, KOH. Understood? We know that we are going to get only alkene, no? We are going to get one alkene. Okay, so if you use alkyl KOH means it acts as a strong base, so it will abstract the proton very easily. So if you use aqueous KOH means it will not abstract proton. Okay, so that's the main difference between this and this. Understood? Okay, so what's the product? Last class we studied, no? What's the product? KBr is removed. Then this OH takes nitrogen from here. The product will be what? CH2 double bond. Last class we studied. Okay. Okay. Now in this class we are going to study about the following. In this class we are going to study about nucleophilic substitution reactions. Okay. So by using aqueous KOH, suppose simple one, CH3Br plus KOH. What's the product? It's called aqueous. Aqueous means mostly we can substitute halogen by OH. So what's the product? CH3 OH plus what? K Br. Okay. So it is classified into studied into 2 types. No, SN1 reaction, SN2 reactions we studied. Okay. What is this? Unimolecular nucleophilic substitution reaction. This is called what? Bimolecular nucleophilic substitution reaction. Understood? So you just make a difference. I'll do some points. You write one by one. Simple one. This is called nothing but unimolecular nucleophilic substitution reaction. Okay, this is called bimolecular. Okay, write in short form. Here rate depends upon the speed of reaction depends upon one means this is it depends upon only substrate. Rate of the reaction depends upon only concentration of substrate. Okay. Here rate depends upon the substrate, nothing but alkyl halides. Alkyl halides, it's called nucleophile group. Okay. If it depends upon both means we can say it's called SN2 reaction. Understood? Rate of reaction depends upon substrate. Substrate means generally we can say it's called alkyl halides. Understood? Nothing but it's called what? Nucleophile. Depends upon both. Okay. It's a first order reaction, it's a second order reaction. That's simple one. You need not write this and all. Priority only is very important. Priority. Okay. Priority means here which kind of alkyl halides involve more in case of SN1 reaction. Okay. In SN1 means here tertiary alkyl halides is more favored than other halides. Here primary. Okay. This is very, very important. Okay. They will give one compounds. Okay. So by using SN1 reactions, or which halides are more favored, they will ask. So this only just memorize. Okay. Tertiary carbocation is more stable than secondary. Secondary is more stable than primary. Okay. But in this case, totally different one. Okay. So I'll give examples you can understand easily. So examples. Okay. Yeah, I'm taking only tertiary. Tertiary compounds, no? Are you following? It's got tertiary compounds. It takes place in two steps. That also important. Step 1, you write step 2. Step 1, nothing but only ionization taking place. You know that. What happened? When it ionizes, C plus, what happened? CS3C, I write it here, after you can write, plus, are you following? C plus, first carbocation is produced. Okay, then step 2, to that carbocation only, who is going to attack? Who is going to attack? You know, nucleophile group, you know, nucleophile, what's the reaction? Nucleophile, we have to substitute nucleophile group. Okay, that's why it's called nucleophilic substitution reaction. Nucleophile means what? It's called nucleophile group. Cn minus, OH minus. Okay, these are all about nucleophile group. Okay, now to the carbocation, now the nucleophile group going to attack. What happened? You get the product CH3, understood? OH, understood? Tertiary butyl chloride becomes tertiary butyl alcohol, understood? Here the bond, here this is, otherwise is called what? We can say retention configuration. Retention means bond breaking and bond forming takes place in same side of carbon atom. Okay, this is called, we can say what? Retention configuration. Write down. This and all important information about this reaction. Okay. Are you following? So when compared to tertiary, secondary, primary, tertiary only can form carbocation very easily. Okay, then only we can, so SN1 reactions, this is more priority. This information, this one, okay, very important. Okay. Wisdom? Then come to this side, SN2, which is more favored. Only the primary alkali is more favored. Okay, primary means I am taking simple one. This comments I am taking. Okay, so mechanism means I'll take this. I'll write like this. Here, Br. You know, it's a smaller group. No, around the carbon we have only smaller group. So the nucleophile group can attack very easily. So this is called, you know, nucleophile group, no? Nucleophile group, nucleophile. See, nucleophile group attacks the carbon atom just backside of bromine atom. Suppose bromine is present here means what? It will attack this side. Okay, then only we can say it's a backside attack. Due to presence of small group, the nucleophile group attacks the carbon atom directly. Okay, but here all what? We have that kind of attack is not taking place here. It's some bulky group is there. Okay, this is totally different one, that is totally different one. Okay, so what happened? Now, slowly one bond is formed, no? OH, one partial bond is formed. Okay, one partial is formed between C and OH. At the same time, the one partial bond is broken between C and Br. So this is called, we can say it's intermediate, or we can say, you know, it's called transition state. Understood? Again, if it attacks severely, what happened? If it attacks severely, the bond is formed completely, the bond is broken completely. So now product what? Now see the product. OH, H. Understood? Okay. See, here, you know, This is always is called, this is I told you, this is called retention configuration. This is called what? Inversion configuration, inversion. Okay, inversion configuration, that's note down, very important. See here, bond breaking and bond forming in different side of carbon atom. Understood? That's why it's called inversion configuration. Understood? So SN2 is inversion, SN1 is what? Retention configuration. Okay. This information, just remember. Okay. Then yes, racemization also. Usually we are saying retention configuration, but here sometimes there is a chance to attack this side. Suppose if you consider this is a planar molecule, okay, suppose you know CS3, 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 it's a planar molecule. Okay, suppose here you know that all the carbocation is a planar. Suppose here carbon is the middle, CS3, CS3, CS3 here. The OH group nucleophile, there's a chance to attack the top, or it will come in top, or it will come in bottom. Okay, there's a chance to come. Okay, then only if it comes top means we get one molecule. If it comes bottom means we get another molecule. These two are racemic mixture. Then only we can say it's called what? Other SN1, other name we can say what? It's called racemization. It forms racemic mixture. Then it is called what? Racemization. Okay. So this is not direct question. You just write. Or we can say what? It's called racemization. Is following? Okay. SN1 belongs to dash configuration. They lost. Okay. It's not direct question. You just remember. Then one more thing. We are saying, now come to the halogens. Which halogen is more, best leaving group means we consider what? Which one is best leaving group? Which one is bigger halogen? Fluorine, chlorine, bromine, iodine. No. So iodine is the bigger one. No. Whenever nucleophile group comes, if iodine is present, it will easily removed from the carbon. So best leaving group that for both, just write in the middle. Okay. So best leaving group, here write it here. Best leaving group means what? Iodide. Next one is bromide. Next one is Cl minus. Next one is fluoride. Understood? Just write. Okay. Understood? That's all. These are the information. Remember, in case of nucleophilic substitution reaction.
Resonance also favors.
Which one?
SN1.
SN1, na? Okay. Chance. You have chance. Suppose here, in this side, any double bond compound is present. Vinyl group is present, there is a chance. Okay. But in this case, only we should say only smaller alkyl group. No, smaller means only methyl, primary. Okay, primary alkyl group only is more favored in case of SN2 reaction. Okay. See, Nijda? Simply, they will give two compounds. Among the two compounds, which SN1 undergoes which compounds? That type of question they will ask. Mostly, see, I will give one compounds. See that CS3, just write. Yes, CS3I or CS3 thrice. Okay. SN1. Which okay, SN1 is favored. Just write like that. Among the two, who will favor SN1 reaction? That's the question. SN1 means what? What is SN1 here? No, SN1 means what? Tertiary. So what? Who will favor this one? Understood? Correct or not? Okay. Sometimes SN2, CS3I or CS3BR. Both are primary. Understood? SN2 means what? This is SN2. Primary is more favored. But see, both are primary. Both are primary means you see the halogens at the same time. Iodide is the best leaving group, I told you. So this is the answer, just note down. Just note down here. I finished. I written SN1, SN2. Okay. Are you following? They will give one compound. You have to find out whether it is SN1 or SN2. Okay. This condition only just remember. It's enough. Okay. Next one is one more properties, important properties, that is, you know that, optical isomerism. What is optical isomerism? Isomerism means?
Same Haloalkane
Okay. Same molecule form but different structural arrangements. We can differentiate by using only light. That's what it's called. Yeah. Optical isomerism. Okay. So here, you know that generally, that suppose if you take monochromatic light, okay, it vibrates in all the direction. Monochromatic light. Okay. Monochromatic light means it vibrates in all the direction. That should be passed into one prism. That prism is called what prism? Nickel prism. After that, emergent ray, it will come, this vibrated in only one plane. Before that, it vibrates in all the direction. After it comes from nickel prism, it vibrates in only one plane. That's why it's called what? Plane polarized what? Light. PPL. Understood? Are you following? Then this plane polarized light passes into, one sample. Sample nothing but, you take one organic compounds. Okay. That organic compounds rotates the plane polarized light in sometimes clockwise direction. Okay. Okay. The sample can rotate the plane polarized light in clockwise direction, or it can rotate the plane polarized in what? Anti-clockwise direction. Are you following? If it rotates in clockwise means we can say it's called dextro. Levo. Are you following? Okay. Or we can say D form, L form. Or we can say plus form, minus form. Okay. The sample means the sample should have some condition. Not all the sample can rotate the plane polarized light. Okay. So the sample, what's the condition? If it rotates means the compound is a optically active compound. Okay. So you write a condition. What's the conditions? If any compounds must be optically active means it's a condition. What's the condition? The compound should have what? Asymmetric carbon atom. Are you following? The compound should have asymmetric carbon atom. Or we can say it's called what? Chiral carbon atom. Chiral carbon atom. What is chiral carbon atom?
attached with 4 different
Very good. Around the carbon atom, all the groups are different. That's why it's called what? Chiral carbon. So suppose here, for example, I write it here. Around the carbon atom, all the groups are different. Best examples, I am taking what? Lactic acid. Lactic acid formula is what? CH3, CH, OH, COOH. Around the carbon atom, all the groups are different. No? Okay. So this is a condition for optically active compound. This compound is present here. It can rotate the plane polarized clockwise or anti-clockwise. Suppose here also we have some percentage will be there. Suppose only D form is present means, D form of lactic acid is present means, we have, it rotates in clockwise direction. Only L form is present means anti-clockwise direction. Okay. So, understood? So, that, write the condition. This is the first condition. Then, what's the other condition? If you keep the substance in front of the mirror, what happen? If you keep, it's a structure. If I keep any mirror means what happen? We are getting mirror images, no? Okay. What's the mirror images? You- Top group and bottom group you write as it is. No changes. You keep just write as it is. This is left. This is in right hand side, no? Okay. This will be what? Left hand side. This is in left hand side, no? It goes to right hand side. Okay. Now you take this structure and keep it on this structure. What happen? Not superimposable. Okay. You take this structure and keep it on this structure means what happen? They will not superimpose. They will not same, no. Okay. Then only mirror images are what? Non-superimposable. Are you following? Non-superimposable mirror images. Understood? These are the two conditions. Okay. Any compounds having this property act as a optically active compounds. Okay. Understood? Just note down. This is one example. Okay. This is one example, lactic acid. Another example also, butanol. Okay, butanol or 2-chlorobutane. Okay, butanol outright. Butanol. Butanol means what? OH, H, cut or not? CH3, H2. Okay, now see this carbon. This carbon, around the carbon atom, all the groups are different, no? This side ethyl, that side H, this side CH3, this is OH. All the groups are different, no? Around the carbon atom. So that carbon atom is called what? Asymmetric carbon atom or chiral carbon. That is represented by asterisk symbol. Okay? Are you following? Here also what? We have asterisk symbol. Okay? So just note down. These are the important conditions. They will give on compounds. You find out whether it is find out the chiral compounds among the following. That kind of question they'll give, or condition for optically active compounds. Okay. The angle can be measured by what? What instrument? No. What's the instrument? How much? The angle. Before it goes to sample, it is going. It is a plane polarized light. No. Okay. After that, the sample only rotates the plane polarized light in clockwise direction or anti-clockwise direction. Any one direction it will rotate. That angle can be measured by one instrument is called what? Polarimeter. Okay. Polarimeter. Yeah. POLARIMETR. Polarimeter. Okay. Suppose, I consider this is a D form, this is a L form. Okay. D only is present here means it can rotate. L only is present here means it can rotate. Okay. Both together means, both together is called what? We can say what? D plus L, we can say what? Racemic mixture. Are you following? Both together in the sample, D form as well as L form, it will not rotate. Because D form can rotate this direction, L form can rotate this direction, so the net optical rotation will be 0. Okay. Even though it contains chiral carbon, you understand? Even though it contains chiral carbon, it will be considered as optically inactive compounds. So simply you can say D form is optically active, L form is optically active, but D plus L form is optically inactive. Are you following? Okay. That's mixture now. Both are there. Both are present in equal percentage. Okay. So the mixture is what? Optically inactive. That's right. That's right. Optically inactive. Are you following? Then enantiomer. Have you heard about this word? Enantiomer?
Non-superimposing.
No. Non-superimposed mirror images. Another term, you just write. No. Write fast. Enantiomer. Enantiomer means here, here D and what is the meaning for D lactic acid, L lactic acid? D lactic acid and L lactic acid. What's the meaning for these two?
Dextrolactic acid.
Both are lactic acid. Both are lactic acid. Only one difference. Optical rotation only different. It rotates the plane pulsation clockwise, it rotates anti-clockwise. That's only difference. Okay. Otherwise, same molecular formula, same physical properties, same chemical properties. Only optical rotation only different. No. That's why it's called what? Enantiomer. Okay. So just write roughly. Same physical and chemical properties, but difference in optical rotation. Same enantiomer. You put the heading, small heading, enantiomer. Same physical and chemical properties, but difference in optical rotation. But difference in optical rotation. Understood? But difference in optical rotation. Okay. See, when compared to receiving mixture and enantiomer, receiving mixture means D and L together you have to see. We have to see how we can see this receiving mixture and enantiomer means, receiving mixture means here D and L's together, no, it's called receiving mixture. But enantiomer means we have to see separately. Okay, D plus L is called receiving mixture. Okay, D and L we have to see separately. Then it's called what? Enantiomer. Okay. Are you following? Okay. This is receiving mixture together. Together means then only it's called optically active. But if you see this one, this also D and L, but you have to only D only we are taking here. Optically active. L only if you take means this is optically active. Okay. Together only it's optically active. Understood? Okay. Right. Okay. Understood. So these are information. Just remember. Mostly what kind of questions they will ask means find out chiral carbon, I told you. Okay, so they'll give on compounds. Okay, so chiral or whether it is optically active or inactive, they'll ask. Optically active means what's the condition? Chiral carbon. The compound should have chiral carbon. Okay, so you have to search. So they'll give 4 options. 4 compounds they'll give. Which compounds is having chiral carbon? If you find out the chiral carbon means we can simply say what it is called optically active. Okay, so a simple butane 2-ol lactic acid. Okay, so 2 chloro butane, 2 chlorobutane outright, 2 chlorobutane, kata H CH3 CH2 CH3. Okay, now see this. Okay, right. Around the carbon atom all the groups are different. Understood? Okay. Any other example is given that book, but textbook mostly butane 2-ol.
Hydroxypropanol.
Butyl.
3-dihydroxypropanol.
Oh, tell me once again. Read it.
Dihydroxy.
3 hydroxy, trihydroxy, trihydroxy, dihydroxy, 3 dihydroxy, propanol, OL, kata? AL, okay, right. 3 dihydroxy propanol altogether, no? What's the structure for this? Propanol, yeah. Propanol means how many carbon? Carbon is 3 only. Understood? Propanol, yeah. Propanol means what? Altogether, CHO. 3, yeah. 3 dihydroxia. Name correct?
Yes, sir.
1, 2, 3.
H2H.
Here 3 dihydroxia. Dihydrox means OH. Correct? Then you can fill by hydrogen. Same carbon. No.
One OH is attached with CH2.
Here.
Yes.
Okay. 3, but name is wrong, no? Name say correctly. Give me the book.
CHOH, CH2H.
Where is it?
Here was it. Yes, sir.
But you didn't say 2, 3.
It's 2, 3.
2, 3 also you should say no. Only 2, 3 dihydroxypropanol. Correct or not? 2, 3 dihydroxypropanol. Okay. Now say that. C. Propanol means 3 carbon. Propanol we have to put CHO. Correct or not? Okay. 2, 3 means this is 1, this is 2, this is 3. Clear? Here one OH, here one OH. Understood? Then you can fill by hydrogen. How to fill up? H. Understood? Here what? CH2. Correct or not? Okay. Now see this, which is chiral carbon? Okay. See here, around this carbon atom, just 4 different groups, no? Okay, around the carbon atom we have 4 different groups. Understood? So that's why this is chiral carbon. See around the CHO, OH, H, CH2OH. All the groups are different, no? That's why this is called what? Chiral carbon. Okay? Right. So following. Chiral carbon means around the carbon atom all the groups are different. Any compounds having chiral carbon that will be act as a optically active compounds. Okay. If you keep any mirror in front of this compound, it will produce what? Non-superimposable mirror images. So these are the 2 conditions for optically active compounds. Understood? Okay. Okay. Right. Are you following or not? Understood? Okay. Okay. Then one more property is organometallic compound. That is simple one. Fifth chemical property is organometallic compounds. Fifth one, organometallic compound we can get from alkyl halides. Nothing but it's called what? Other name is called what? Grignard reagent. What's the Grignard reagent formula? RMgX. Understood? We know Rx plus Mg is added in presence of dry ether. We get what? RMgX. Yeah. Our chapter is what? Haloalkane. No. You take an alkyl halides, magnesium is added. In presence of dry ether, as a solvent to get RMgX. So if you want to get means CH3Br plus Mg. What's the product? CH3Mg Understood? Okay. Okay. Here, why we can say metal means here metallic compound means organic group is also present, metal is also present. That is called organometallic compounds. Okay. Then here one more thing is very, very important. One property is here, that is hydrolysis property. You take this compound, Add water. Water for convenience I am splitting like this. Okay. Mostly, you just remember, one alkane is obtained here. Alkane, mostly here, what is this?
Group attached with H.
Mostly alkane is obtained. What is the alkane? What's alkane obtained here? CH4 plus, this is a subproduct. You don't worry about this product. Okay, suppose here, if I take alkane, we can say, or generally we can say hydrocarbon. Generally we can say, okay. Now tell me. What's the product? Sorry, this is what C6H5. Okay.
C6H6.
6. The hydrocarbon I'm saying. Hydrocarbon, mostly hydrocarbon only is obtained. Okay. Product is what? C6H6 plus
MgOH.
okay, Br. Okay, understood. Okay. They're asking like this. CH3MgBr ethanol. Same product now. One H only will come here. So product becomes methane plus what? CH3Mg, Mg in the middle, one side Br, one side OCH5. Okay. Anything we can say. It's called only simply hydrolysis. Okay. This is called alcoholysis. Hydrolysis, alcoholysis means water is also a solvent, alcohol is also a solvent, Okay. So but anyhow we are getting what? Only hydrocarbon is obtained. Just remember. Okay. Here also we are getting methane. Okay. You want me to just write one equation instead of
Water, alcohol and amines.
Amines, if you add means what's the product?
Same hydrocarbon.
Hydrocarbon. Okay. They asked one time, I think 18 or 19. Okay. Grignard agents are hydrolysis to get dash. Okay. Mostly just remember, product will be hydrocarbon. Okay. Right. That's all, ma'am. This is about haloalkanes we completed. Okay. Next one is haloarene. Haloarene means example. Haloarene example, chloro. Benzene. Best example, chlorobenzene. Okay. Halon is attached to arene. Arene means benzene, no? Okay. What kind of carbon this is? Sp?
3.
Sp2. What kind of carbon this is? It's called Sp2 carbon. Understood? Okay. Huh? No. Okay. 1, 2, 3. Kata. 3 sigma bond, 1 pi bond. So what? 3 sigma bond means automatically it's called what? Sp2 carbon, isn't it? Right. Preparations. Only one preparation I'm going to give. Sandmeyer reaction. No. What's Sandmeyer reaction? Not the Sandmeyer reaction. It consists of two preparations. Sandmeyer reaction as well as diazorization, both together. Diazotization. See, two reactions are diazorization and Sandmeyer reaction together in the same reactions. See, I am going to get chlorobenzene from what? Aniline. You know that. NaNO2 plus HCl 273 to 278 Kelvin. Just remember, it's called diazorization. Understand? If you see this reagent, you must remember what it is doing means it converts what? NH2 to what? N2Cl. Okay, NH2 to this reagents convert NH2 to what? N2Cl. Again, you can add any cuprous chloride or any we want to get only chlorobenzene, yeah, you add cuprous chloride. Okay, what happened? So N2 is removed.
Copper also okay.
Huh?
Copper also okay.
Copper?
Copper chloride.
Oh, that's a Gatterman reaction.
Sir, you
Ne-
use powder no sir in Gatterman.
Gatterman copper plus HCl. But here cuprous chloride plus HCl. That's the only difference. Only availability. Suppose if you have cuprous chloride means we can use cuprous chloride. Or if you have only copper means copper we can take. That's the only difference. Okay, otherwise everything same. Okay, process and all same. Always N2 what? Is a nothing but it's called unstable compounds. Then only N2 will be removed. Okay, so what? Remaining? What's the product? Tell me. Chlorobenzene. That's all. If you add cuprous bromide means we are getting bromobenzene. Okay. If you add cuprous iron means we get whatever halogens we are adding, that kind of compounds we are getting. Understood? Okay. Gatterman reaction one is there. They are saying only available. If you have cuprous chloride means that is considered as a Sandman reaction. Another scientist he also did to find out prepare the same compound, but he used copper.
Powder they gave sir.
Only?
Form of powder.
Which powder?
Copper chloride powder.
This copper powder.
Powder they are taking na it's Gatterman reaction like that.
Copper chloride powder. Only copper powder. See that reactions.
It's copper powder.
Only copper powder. It's called cuprous chloride means only availability they are saying. So naturally, if we get more amount of cuprous chloride means we can use this Sandman reaction. Copper if you have means Gatterman reaction. That's all. But method is same both. Okay. Are you following? Just note down. If you want means just copy them this one. The reagent just memorize. Okay. They'll give question mark here. Find out. Okay. Here also they put find out question mark. Okay. The reagents, so many places it will come. It comes in amines also. Okay. It comes in amines. The same reaction comes in amines as well as alcohol, phenol. Phenol it will come. Understood? Understood? Finished? It's enough. One method is enough. The other method we already studied in the haloalkane. You know or not? Toluene plus chlorine in absence of sunlight.
Yes sir.
Presence of sunlight, absence of sunlight. Yesterday we did know. But it's not exactly chlorobenzene. It's chlorine derivatives. Halogen derivatives compounds we studied. Okay. Put the heading Haloarene. This is an example. Okay. It's one method to prepare. It's enough. I told the free radical halogenation reaction. Presence of sunlight, absence of sunlight. I told presence of sunlight we are getting, that benzyl chloride is obtained. Absence of sunlight, absence of sunlight only orthochlorotoluene, parachlorotoluene. Okay. Because chlorine should be attached to the benzene directly. Then only it's called what? sp2 carbon. Okay. CH, this is totally different, no? Both are different, no? This is called what? This is CH2Cl. This is what? This is called aryl halide. This is called benzylic halide. This is called aryl halide. This is called benzylic halide. Understood? This is chlorine is attached to sp3 carbon. Here chlorine is attached to sp2 carbon. Following? Brilliant. Understand or not? Are you following? Chlorine is attached to sp3 carbon. That's why it's called benzylic halides. Here chlorine is attached to sp2 carbon. That's why it's called arylic halides. Understood? Okay, right. Preparations only, just copy them. That's all. Now, only two properties are there, most important properties. That is, Okay, first one. Chemical properties. Okay, simple one. First one, nucleophilic substitution reaction. Nucleophilic substitution reaction. Understood? You know that you take chlorobenzene, reacts with sodium hydroxide, 623 Kelvin, 300 atmosphere pressure. That reaction is called what? What is this? What's the name of the process? Process is called what? Dow's process. Remember? What's the product? NaCl will be removed, OH is added. Understood? So it becomes what? Phenol, no? Phenol. Okay? Are you following or not? Simple one. NaCl is removed, OH will be added here. Okay? But it's not added very easily. Then only we are giving this much temperature and this much pressure. Okay? Because directly, if you want to add anything to benzene ring, very difficult. Because mostly it's called aryl halides, no? Mostly aryl halide will not undergo what? Nucleophilic substitution reaction. Why? Okay, the reason is very important because then only this much temperature they are giving. Otherwise, if you add only sodium hydroxide, means the reaction will not taking place. Understand? So aryl halides will not undergo nucleophilic substitution reaction. Why means? Simply I'll give one. This undergo resonance. First point is resonance. Okay, suppose Okay, here 3 lone parafluoride will be there. Are you following? One comes here. Tell me, it undergo resonance. How it will be? We are thinking it is a single bond Cl. But actually what? Due to resonance, it will be what? Double bond Cl. Understood? This will come, make a bond. This bond will break. Understood? So here it will be minus, here minus. Understood? Okay, now what? It comes here. Charge become bond, bond become charge. Just remember like that. Okay. Charge become bond, bond become charge. Understood? Okay. It goes on. Okay. Okay. So now, if you want to replace Cl by OH means how it is? It is a double bond, no? Okay. Due to double bond character, this will not happen. Understood? The reason is, just write the reason. Okay. Due to double bond, partial double bond is given in your textbook. Okay. Or simply write partial double bond. It's not on. Very important. They'll ask in reason assertion question. Okay, why aryl halides will not undergo nucleophilic substitution reaction? Reason is, one of the reason is partial double bond by resonance. This is one reason. Okay, another one is, what kind of carbon? This is what? sp2 carbon. Okay, chlorine is attached to what? sp2 carbon. Chlorine is attached to sp2 carbon. Okay. These two reasons is enough, I think. That character and all sp3 carbon, sp2, this all or not? sp3, sp2, sp. This electronegative tendon, this is more, yes. Sorry. In the sp3 hybridization, S character is how much? sp3 na one s orbital, no, 3 p orbital. So totally, if you take the ratio 1/4, 1 by 4 means S character is what? 25% S character. Are you following? Here what? 33% S character. Okay, this here what? Equal 50-50. S character is 50, P is also 50. Okay, then only it's more electronegativity. Okay, so if any halogens are attached to this one, very difficult to remove. Understood? Okay, suppose here, see, which is more hydrolyzed? Which is more easily hydrolyzed? The second one. Understood? Here, see the chlorine. Chlorine attached to which kind of carbon? Sp. What type of carbon this is? Yeah, sp3 then Elia. You put one hydrogen top, you put a hydrogen down. Around the carbon atom, how many bonds are there? Brilliant. CH2, just imagine, 1H top, 1H down. Around the carbon atom, how many sigma bond? Yeah, 3. 4. 1. 2. 1 hydrogen top, 1 hydrogen down. How many sigma bond? We have 4 sigma bond. 4 sigma bond means what? sp3. sp3 means what? Electronegativity is what? Somewhat less. Okay, so less means we can easy to add OH. But this is what? sp2. Okay, it has more electronegativity. It holds the hydrogen. It holds. Okay, so we cannot easy to substitute OH group. Okay, so among these two, this can be easily hydrolyzed. Are you following? Okay, just right. The reason just right. The two reasons very important. This is very important due to double bond character by resonance, due to sp2 carbon. Okay, right. Then only we are giving this much temperature. Understood? Okay. Understood? Suppose you cannot able to give the temperature. So, sorry sir, I have no facilities to give any temperature and pressure means we can substitute what? Anyhow, we can substitute any electron withdrawing group. Instead of temperature, if you give any electron withdrawing, if you substitute any electron withdrawing group means we need not give much temperature. Suppose here, based upon this, we have, see that, you just write like this. See, just note on this now. E, what is the meaning for this? Electron withdrawing group. If you increase the electron withdrawing group, nucleophilic, I simply write nucleophilic substitution increases. Just note only. Okay, see. Listen, chlorine, I put one NO2 group here. Okay, what happened? Which means need not give that much temperature. The textbook they put only, I think only 443 Kelvin. Okay, next one. Chlorobenzene, NaOH, 3, I think 368 something. Okay, Kelvin. Okay, I introduced 2 NO2 group. Are you following? Then this is one. I introduced 3 NO2 group. I introduced 3 NO2 group. Okay. Need not give that much temperature. Temperature decreases. No NO2 group, 1 NO2 group, 2 NO2 group, 3 NO2 group. Okay. Say due to electron withdrawing group, need not give much temperature. This bond is somewhat weak. Bond is weak means it will be easily removed. We can easily add OH group. Understood? Okay. Now they are saying just warm. Okay. Product you don't know. All the product you know or not. Cl by no. What did come here? OH. All the cases we have OH. OH, OH, OH. Understood? Okay. Here, they'll give one trend they will give. Suppose I consider this is compound 1, this is compound 2, this is compound 3, this is compound 4. Who is more reactive towards nucleophilic substitution reaction? You take this chlorobenzene, you take this para-nitrochlorobenzene, you take 2,4 dinitrochlorobenzene, you take 2,4,6 trinitrochlorobenzene. Who is more reactive? Who is more reactive means this is less reactive because that much temperature and pressure is given, then only reaction takes place. So who is more reactive means this is more reactive. Understood? Need not give anything. Just if you add, just warm the solution, automatically the Cl becomes what? OH. Understood? Okay. So this nucleophilic substitution trend. Are you following? So what? 4, 3, 2, 1. Just note. Be quick. It makes the CCl bond weak. That's the purpose for this one. Okay.
So they gave nitrophenol, sir. For second one. Phenol.
This one, all the cases you should add NO2. Here also, you do yourself. This only changes. Instead of Cl, OH will come all the cases. Okay. Suppose I put only NO2 in para position. Sometimes ortho and para means if you NO2 in para position only, more tendency to withdraw the electron from here. Suppose if you take here one chlorine, orthonitochlorobenzene, this is what? What is this? Para-nitrochlorobenzene. Okay, among these, who is having more tendency? Both are having one NO2. But who is having more tendency to withdraw the electron means they are saying para. This also remember. Okay. This is easy to understand. No NO2, 1 NO2, 2 NO2, 3 NO2. This is easy to understand. But we are both having one NO2. But if any NO2 is present in para position only, having the tendency to withdraw the electrons more. Okay, right.
First para, then ortho, then
Yes. Okay. This you can easily differentiate, but this one, both are having one no. So para only having more tendency to withdraw. Understood? Okay. Next one. Copy it or not, please. These are important. Let's go through. Very important. Okay, S character. Okay. They will give one compounds. Which compounds having S character is more? This S character. 11th standard they will give only sp3, sp2, sp like that. Okay. Which compounds having S character is more? But in 12th standard portion they will give one compound. First of all, find out that compound belong to which category? sp3 or sp2 or sp. Okay. So first find out the hybridization. Next one we can find out what character, S character. Okay. It's all important. Okay. Then only next one is electrophilic. Electrophilic need not study all this. Only you should remember what kind of character. Ortho para directing or meta directing. So meta directing we have only, it comes in only in aldehydes ketones, that chapter only. Others, all the compounds are what? Ortho para directing group. That only remember is enough. Electrophilic substitution reaction. Okay. First, just remember here chlorobenzene, what kind of director? This only just note down. Ortho and para directing group. So only one example, just note down. Nitration. If you do nitration, what happens? They'll give the comments, they'll give the questions like this: concentrated nitric acid and concentrated sulfuric acid. What's the product means? Understood? I told you, no, what is this? Just one, this only just mentioned, that's all. This only is enough. Okay. All the reactions are looking same. Okay. What kind of directed? So we are getting ortho product as well as para product. Which is more stable? Para. Stable product, major product. Understood? Okay, here no steric effect, and only it's a major product. Okay, just note down.
They asked it in board exam.
Yes.
Why it is major product?
Why? Okay. What do you written?
Due to.
Due to steric effect. That's a important point. Okay. Here it will attack some groups are nearby. No. Here no groups are nearby. So here no steric effect. This is a major product. Okay. This year CPSC very nice paper. If you know the concept, then only can able to attend. Yeah. So if you study only the simple important question, means you cannot touch the paper. But you can get marks. Out of 70, you can get 30, 35 ranges. If you study only important question. Okay, but if you know the concept and practice more question answer, means you can cross more than 60 or 55 like that. Okay. Like a second paper, no? Chlorination, acylation, alkylation. So this only just remember. Okay. Others just refer book. Just when classwork itself, you just refer book. Others are same. Okay. Then next one is metal. Reaction with metal. This is very important. Name reaction. Third one is reacts with metal. Okay. For simple. I already told you. This one, if you want me to just write. Woods reaction means what? Both are alkyl halides. Just write, note down. If you have Fittig reaction means what? Both are aryl halide. If you have Woods Fittig reaction, Woods Fittig reaction, one is alkyl halide, another is what? Aryl halide. Other is, just note down. It's important. What's the meaning for this? Woods reaction means both are alkyl halides. Both are alkyl halides means what? I already told you this one. Yeah. Both are alkyl halides means what? Suppose for example, CH3, CH2, Cl. What is called alkyl halides. Okay. Both are alkyl means we should write 2 times, no? Na, Cl. What's the product? Understood? No. CH3. CH2, CH3. Understood? Following. Okay. Yesterday I told you, the same Woods reaction. Yeah. Just compare and study, then it will be easy. Okay. Then this one. Fitting means both are Aryl halides. Aryl halides means what? C6H5Cl, again 2 times Na, understood? You remember like this. Product is what? NaCl, NaCl, okay, gone. C6, S6, C6, sorry, C6H5, no, sorry. H5, C6, H5, okay, it's called biphenyl or diphenyl, both are the same. Understood? Then, Woods fatigue means what? Woods fatigue. One is alkyl halides, one is aryl halides. Aryl, okay. Alkyl means you can take this one, aliphatic compounds. So, CH3, CH2, Cl, two times sodium. Aryl means what? CH5, Cl. Okay, NaCl, NaCl will be removed, no? Product will be C6H5, CH2, CH3. Understood? That's all. Just note down. Understood? You compare and study, then only say here, study all the name reactions based upon, only they will give some questions. Sir, I given the problem solving session, 7 problems in haloalkanes and haloarene. So if you study all this concept, you go through means you can able to answer this problem. Okay, just go through each and every chapters. We are giving 7 problems. Okay. Suppose how they lost means, you know, what's the answer for this? What is A, what is B? A is, you know, presence of sunlight na replace sp3 hydrogen. Here no sp3 hydrogen, all are sp2 hydrogen. So answer is chlorobenzene. Okay. What is B? A is, you know, chlorobenzene. Correct or not? What is B? Fatigue. See the fatigue reaction. Sodium, if you see means you must know. It may be among the 3, any one. She says aryl halides, no. Aryl halides plus Na. Don't remove NaCl, don't say benzene. Diphenyl. This also you write 2 times. This also you write 2 times. I written no here. 2 times. So we get what? So B is what? Therefore, B is what? Biphenyl. Understood? Just note down. Right. Copy them, this one. Copy it or not? Huh? Read down. Understood? This one I have given in the problem solving session. I gave some 7 problem. This one I have given. Alcoholic AOH. Tell me that. A, B, C.
So for alcoholic OH,
Hmm.
CH2,
Hmm.
CH2.
So, okay, first tell me A. What is A? Sodium. You see, sodium means Woods reaction. You think this is 2 times. This is also 2 times. Ah. This is called what? CH3, CH2, CH2, CH3. Nothing but what? Butane. Following. What is B? Aqueous, no. Aqueous nucleophilic substitution reaction. You know, what's the product? KCl will be removed. What's the product? Ethanol. Correct or not? Aqueous. This is alcoholic. Alcoholic means rules and regulation will be there. Beta elimination reaction. Clear? KCl is removed. This OH takes hydrogen from beta carbon. So product is what? Kata? Ethene. Understood? Just note down. This kind of question only we can expect in this chapter. Just note down. Finished? Only one problem I'll give. Identify tell me, be quick. Identify A and B. It's a question. Identify A and B. Alkene HBr. What is this? Markovnikov rule. Yesterday I told you, no. Alkene HBr. See that? Side matra preparation. Alkene HBr. Okay. When alkene is there, when HBr is there, immediately you should remember it's called Markovnikov rule. What happened? Now see that? CH3, CH2, CH, double bond CH2. Understood? HBr, what happened? Plus minus. Okay. Plus minus. Tell me. Negative part goes to carbon atom. Negative part. This is having only, it's having one hydrogen, it's having two hydrogen, no? Negative part goes to carbon atom which carries less number of hydrogen. Positive part goes to this side. Okay, that's the Markovnikov rule. Understood? Okay, now product will be, what's the product? CH3, CH2, CH, kata, Br, down. Okay, CH3. This is compound A. Understood? 2 bromo, 2 bromo, butane. It's a chiral carbon, correct or not? Chiral carbon, no? Okay, right. Again, alcoholic KOH. If you put alcoholic KOH, what happened? Which rule we can follow means sets of rule. Both are beta carbon, no? Alkyl KOH na, this is alpha carbon. This is also beta, this is also beta. Which beta hydrogen we should take means only this side. Then only we are getting the stable alkene is obtained. Long chain, that's one condition, easy to memorize. But if you take this side, then only we are getting stable alkene is obtained. Okay, tell me. CH3, CH, understood? Double bond, CH, that or not? This is B, just note down. Butene. It's a B, 2 bromo butane is A, understood? Right. Are you following? From all, see, this will be removed, KBr, correct? Then OH from which carbon? Beta, beta, both beta is there. Which beta we should take means this beta only we should take. So what? H2 will be removed. So in between alpha and beta, the double bond will come. Understood? Why this reaction does not taking place? Markovnikov rule we cannot able to follow, or anti-Markovnikov rule also we cannot able to follow, because if you put we put dotted lines, no, which carbon having less number of hydrogen? Both are say no, then only not. Why? Understood? We cannot differentiate, no. So if we cannot differentiate means butene not undergo Markovnikov rule or anti-Markovnikov rule. Okay, we have to differentiate less number of hydrogen, more number of hydrogen. Understood? Okay, note down. Application you just go through yourself. Only I told you in the beginning, no, DDTs. I told you, DDT is very important. Did nothing but dichloro-diphenyl trichloroethene, then phosgene, freon, carbon tetrachloride. Okay, you just go through. Only properly just underline and prepare. Okay. Written. So please finish up. A, I mentioned correctly. What is A? 2 bromo butane. B is butene. Okay, right. Finish now? Okay. Any doubt? Go through all the reactions. Okay, most importantly I given in your class work note. All the reactions you go through. You study 3 or 4 times and see the we are giving one video, that video, see the sounds, you can able to understand all this. Okay. Understood? Okay. That's all this lesson. There is also ortho-para-directing. Friedel-Gauss reaction means what? Alkylation, acylation. Alkylation means alkyl group added to ortho position. Acylation means acyl group is added to. So same, similar, you can able to study that. There is also an amine reaction, important only. Okay, but for all the electrophilic, you just study. You must know what kind of director, ortho-para director or meta director. If you know this, that's all are looking same. sulfonation, nitration, halogenation, alkylation, acylation. Okay. Okay, that's all. After 10 minutes, I'll start the new lesson. Okay. We have break for 10 minutes. Okay, after 10 minutes I'll take. Okay. Okay, ma. Okay, now see, we completed one lessons. Yeah, Haloalkane, Haloarene we completed. Now we're going to see one lessons in inorganic chemistry. Okay, D block elements. So whatever I'm giving, just note on all this. All the points are very important. Okay. Okay. So only we are going to study about only the properties of D block elements. We studied already. You know the periodic chart. Periodic chart means how many groups are there? How many groups? Periodic chart. 18 groups. You know that. Yeah. Okay. First 1 and 2 group who is occupying? First 1 and 2 group is called S block elements. You know that. Yeah. S block. Then you know 13 through 13, 14, 15, 16, 17, 18. Who is occupying? P block elements, you know that. Yeah. Then in between we have D block elements, isn't it? Okay. Understood? So here 3 to 12, correct or not? 3 to 12. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Understood? 3 to 12 who is occupying? It's called D block elements. Understood? You know that. Okay. Okay, first we have what is the important thing means here we are going to study about some general properties of D block elements. Okay. Then we have two compounds given. One is KMNO4, another one is called K2Cr2O7. Okay. Then we are going to study about F block elements. There are also only properties. Okay. So here, so I think mostly they'll ask any question means only from the properties of D block elements. Okay. So study all the properties. Here reason also we have each and every properties we have some reasons. Okay. These elements act as a catalyst. These elements act as a form complex. Okay. These elements will be colored. These elements having high melting point. Okay. These elements forms alloys. Okay. So all the properties you must know the reason. Okay. So sometimes theoretically they'll ask any questions. Okay. Then some problem means here how to find out magnetic moment. There is only one problem, small problem. You know, if you know the formula means you can easy to solve them. Okay. Okay. Simple one. You know the periodic chart. You know S block, P block, D block. Okay. So it occupies what? D block elements occupies 3 to 12 group. Correct or not? Okay. It starts from actually here first. This is not a first period. This is what here. This is the first period. No. Here first period 1. Okay. 18. This is what hydrogen and helium is present in first period. Understood? You know that it's all studied in lower classes. 1, 2, 3. Okay, right. There are how many periods? 5, 4, 5, 6, 7. 7 periods. You know that. Okay. Now we are going to study about only the D block elements. So D block elements, you just concentrate. Okay. So here it occupies 3 to 12. Okay. Then what is general electronic configuration? General electronic configuration is what? General electronic configuration is general electronic configuration. Tell me. N minus 1, D, 1 to 10, NS2. Correct or not? The general electronic configuration. Okay. it starts from fourth period, no? It starts from fourth period, fifth period, sixth period, and seventh period. This periods only it occupies. Okay. So classification means we can classify these elements into what? Four types, no? Classification. Classification means we have, see this, if it is present in fourth period, no? So 4 minus 1, 3D. So this is fully 3D series, 4D, 5D, 6D series. Understood? They classify into 3D, 4D, 5D, 6D. Understood? Are you following? 3D series, it starts from scandium, ends with what? Zinc. Okay. 4D series starts from ytterbium, ends with, cadmium. It starts from here. Now the sixth and seventh period, who will come? Both D block as well as F block will come. Here the F block, here F block, here lanthanum to lutetium. F block is present. 57 to 71, they pull and keep it under the periodic chart. Okay. Actually, here we have only 9 elements are there. I think it starts from what? Osmium, osmium to mercury, HH, remember. Okay. Then here also, F block elements present, lanthanum to lutetium. No, this is called, actinium to lawrencium. Here is fully what? F block elements. Now it starts from only here, D block elements. Tell me, it is rhafnium, no? Rhafnium to, copernicium, Cn, copernicium. Okay. So these are all, they are classified into 4 types of D block elements. Understood? Okay. Then sometimes we are saying zinc, cadmium, mercury is not a D block elements. First of all, you should know what is D block elements. How will you say, when you write the electron configuration, its last electron present in what? D orbital. You know that. Or simply you can say incompletely filled D orbital. Are you following or not? Incompletely filled D orbital is called what? D block element. The elements which is incompletely filled D orbital is called D block elements. Understood? That is one definition. Or we can say the last electron in D orbital. When you write the electronic configuration, last electron present D orbital is called what? D block elements. Okay? Right. But if you take these 3, what? Why it is not a D block elements? Not a D block element. Why? Because it's not a D block element. I am saying. What is D block element? What is D block element means? Incompletely filled D orbital is called D block elements. That's a completely filled. Okay. One silly question they will ask. Okay. They put in D block, but they are saying it is not a D block. Why they?
Why zinc is not transition?
Why other name? Other name is called what? That also remember. What is called? What is called D block elements? Transition elements, because it is present in between. It has the property of both S block and P block. It's a bridge elements, you can say. Understood? Then only it is kept in between, S block and P block. Understood? Okay. Not a transition element means because due to what? Due to completely filled. When you write the electronic configuration, completely filled what? D orbital. This is all you know. Okay, right. Understood? Configuration study is very important. N-1. Okay, right. This is all just note down. You want me just write fast. Understood? They classify into 4 types. Okay. 3D, 4D, 5D, 6D. Okay. It occupies 3 to 12 group. Okay. It starts from fourth period. Electron configuration n minus 1d 1 to 10 ns2. Okay. All are metals, correct or not? All are metals. Okay. See, this also is just not, but we will see later. Anyhow, zirconium, just right. Zirconium, D block elements, no? But osmium is also D block elements. Okay. These two having similar radius. All the points you just write. Zirconium and actually who is big in size? When you go down the group, size increases, no? So who is big in size? HF. HF means osmium. Big in size. This is not smaller in size. Okay. But they are saying they have similar radius. Similar radius. Due to what? What is the reason? Due to study it. Lanthanide contraction. Here lanthanide comes, no? Lanthanide. Here F orbital will be there. F orbital is a poor screening effect. So actually this should be big in size, but due to poor screening effect of F orbital, this also looking same. Both the elements are looking. The reason only just memorize. Due to lanthanide contraction. Due to lanthanide contraction. Okay, right. Very fast. All the points you just register in your note. Now general properties. Now general properties of D block elements. Okay. General properties. See. Okay. Nearly 10 properties are there. Okay. Just I'll give some important points. Just note on one by one. I written all this. Okay. Okay. You just memorize first transition series. Other is called first transition series, second transition series, third, fourth, like that. Okay. First transition series just memorize because it will be very useful to study coordination compounds as well as this lesson. Okay. Sometimes here NEET examination they won't give the atomic number, but CBSE board examination they will give atomic number. Okay. But anyhow, then only just memorize the first transition series, all the elements, atomic number. It starts from 21, ends with what? 30. Okay. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel. Iron, cobalt, nickel. You just study like that. Then copper. Understood? Atomic number 21 to 30. Understood? Okay. You know that. Okay. This is the introduction about the D block elements. Now we are going to study about the general properties. Okay. Nearly 10 properties are given. So first one, you can easily to say when you atomic radius. What happened to the atomic radius? We are studying these elements. It's a period wise. No, we are seeing this element first transition series, second transition series. Yeah. So we are seeing these elements in period wise. So what happened when you go from left to right? Top to bottom atomic size increases or atomic radius also increases. But when you go from left to right, atomic radius what happened? Decreases. No, decreases. No, top to bottom increases. Yeah. Atomic radius or atomic size, anything, any same. When you go from left to right, atomic radius or we can say atomic size, both the same. Okay. So atomic size decreases due to what? Nuclear charge increase. Just remember. Okay. When you see in left to right, only this is the only reason. Nuclear charge increases. Okay. But sometimes it decreases. Sometimes slightly increases. In our textbook, one graph is given. So it decreases up to chromium. After that, it will be maintained. Okay. So it will be like this. When you plot atomic number and atomic radius, it decreases. When the atomic number increases, it will be decreases. Then after slightly increases. Okay, so slightly increases due to one more factor is also coming. That one more factor is called, we can say, shielding effect. Shielding effect. Okay, shielding effect means here, if you put more electrons in d orbitals, no, that will shield the nucleus more. So the nucleus is shielded means nucleus cannot able to attract the outermost electrons very effectively. So that sometimes slightly increases due to two opposing factor. This only no doubt. Okay. We have only one factor means no problem. It decreases gradually. Okay. But here two opposing factor will be there. Shielding effect is also there. Okay. That's the reason. Okay. Atomic size decreases when you go from left to right due to nuclear charge increases. Okay. Right. Next one. Okay. Then next one is, melting point. Mostly all are metal, no? Okay, it is having high melting point. Okay, so high melting point due to only one reason they are giving. So when you go from left to right, number of d electrons increases, no? Okay, understood. Scanning having 1 d electron, here 2 d electron. It goes on like this. Okay, so why it is high? It is high, it is high melting point due to the reason is more electron in d orbital. This one point. Okay, so if you have more electron means it can make bond form. It can, okay. So bond form, the electron which is involved in bond formation also more. Then only due to more number of electrons in d orbital, it is high melting point. They are saying. Another one is important one is here, enthalpy of atomization is also high. Enthalpy of atomization. What is the meaning for this? Enthalpy atomization, enthalpy means heat energy. The energy required to convert this metal into atom. Okay, so metal is made up of atom, no? If you want to split the metal into atom means we have to spend more energy. Okay, so because the atoms are nearer, okay, it's closely packed, no? Metals having high density. Okay, so they are all closely packed. So if you want to separate atom means we have to spend more energy. So enthalpy of atomization is more. Then only it's having high melting point. Okay, the reason is given. So many reasons given. This is the most important reason. There is no doubt. Okay, right. Then in the graph itself, they are given like this. See the graph they put like this. Scandium, titanium, vanadium, chromium, up to chromium here. The manganese they put down. After that, iron, cobalt, nickel. What is the meaning for this graph? It's called melting point, no? It's called atomic number. Okay. D1, D2, D3, D4, again D5, okay. D5 means, what's the configuration of Mn 25, that's 3D5, 4s2, 3D5 liya. Understood? All are, due to off-field configuration, even the 5 valence electrons are there, or even the 5 electrons are there, due to off-field configuration, no one can participate. Understood? Okay. If suppose, are you following? Due to off-field configuration, okay, no one can participate means no one can bond form. no one can participate in bond formation. So that it has what? If anyone can form bond means it has high melting point. Here in manganese, no one are ready to involve in bond formation. That's why it's called by low melting point. Understood? Okay. What about zinc? Zinc, tell me. Zinc. Huh? Fully filled. Is there any D means more electron in d orbital. If you want to say very correctly means more unpaired electrons. That's the correct one. Yeah. But in zinc what? 3D10. Is there any free electron? No electrons are involved. So zinc having what? Melting point? Low. Yeah. No free electron. So it will not make a bond. It will not make a bond means what? We can use to break the bond. Okay. So no free electron means that elements having low melting point. Just remember. Understood? Okay. Just note on. These are the information. Just note on about melting point. Are you following this? Manganese also low. Zinc also low. Manganese, even though 5 electron, but due to what configuration? Due to off field. Are you following? Due to off field configuration, it is low. It is low melting point. Understood? Okay, right. This is due to full field. Correct? Understood? The only one reason. Okay. All electrons are paired. Okay, no free electrons are. Huh? Copper also. Copper. 3D10 4s1. Okay, but when here also we can say. Understood? But copper 2 plus, zinc 2 plus, even though zinc 2 plus, we have 3D10. But copper 2 plus we have, are you following? In zinc 2 plus we have 3D10, copper 2 plus we have 3D9. Now we are getting 1 unpaired electrons. Okay, so when compared to this is very low melting point. Here somewhat high. Sorry, very low melting point, here it is somewhat high. That's all. Okay. See that. These are the information about melting point. Okay. So, following. Right. Next one. Chart, just remember. Okay, chart. From the chart only we can explain. Next one, you know that ionization energy. What is ionization energy? What is ionization energy? The energy required to remove loosely bound electron from an atom in gaseous state. No? Okay. So, how much energy is given to remove electron from an atom in gaseous state? That's called ionization energy. Suppose here copper, no, it will be like this, no. Okay. If you suppose copper, you take, how it will be? 3D10, 4s1. What happened? If you give some energy, which electron is going to remove? First of all, wow, 1 electron in s orbital only can remove, no. Now it will be what? If you remove 1 electron means first ionization energy. So it will be what? Cu plus. Understood? Now, in Cu plus, what's the configuration? 3D10, 4s, 0. Next one. Can you remove an electron from here? Can you remove an electron from here? No, why? Okay. Due to completely filled. No. Understood? Are you following? If you want to remove electron means this electron we can easily remove. When you go to second stage, if you want to remove one electron means what happen? We can't remove because this is completely filled. So who is having high? I2 or I1? I2. Are you following? I1 means if you give some energy, we can remove electron from s orbital. When you go to I2, if you give some energy, because due to fulfilled configuration, we have to spend more energy. So I2 is always what? Higher. Okay, just note down. This point just write as it is. I'll give one examples. See, ionization energy is nothing but the energy is given to remove electron. If it is already stable means we cannot remove. Okay. Now tell me this one. Mn 2 plus Fe 2 plus. Mn 2 plus Fe 2 plus. Which one having high ionization energy? Manganese. Okay, correct. Mn, first we write for Mn. Mn is what? 25. So 3d5, 4s2. Okay. Sure. At the same time, we should see the which suppose if you remove one electron means it will become 4s1. Again, if you remove one electron means it becomes what? 4s0. Okay. When you go to third one, here third only we should say. Manganese, sorry, manganese is one. Iron is what? Tell me. Iron is 26. 3d6, 4s2. Okay, ma'am? You following or not? If you want to remove first electron means what happened? IE1. It becomes what? Tell me. 3d, 5, 4s1. Again, if you remove one electron means IE2. 3d, 5, 4s0. When you come to third one, due to off-field configuration, it is I. Come this way. IE1, 3d6, 4s1. Understood? IE2, 3d6, 4s0. IE3. Now we just compare the IE3 only. Very difficult to remove, no? But here can remove. Okay, partial field configuration. So IE3 having what? Third ionization energy of IE3 is IE3 for Mn 2 plus is greater than Fe 2 plus. Understood? Just note down. Okay. Okay, right. That kind of question they will ask mostly. Okay. Understood? Usually first ionization energy always lower. Okay. That's a general question. You know, you study in alkali metal, alkali earth metal, you study, no? Usually, you know that first ionization energy always lower, no? IE1, tell me, it becomes what? Na plus. Now it becomes 2,8. Who is higher? Who is higher value? IE2 or IE1? Free or the electrons are very free, no? We put some energy, we can easily remove. After that, this is atom, this is ions. We can remove electron from atom, but we can't remove electron from ion because it's called positive character. Okay? Very difficult to remove, no? In this case also what? IE2 is greater than IE1. Always the higher potential is always greater than lower potential, usually, generally. Okay? Right. So note down. Okay. Reached up? Okay. This kind of question they'll give mostly. Okay. Sure. So then only you study the atomic number. Atomic number, if you are familiar, means you can able to answer this one. Okay. Right. Then fourth one is oxidation state. Oxidation state. Oxidation state mostly. So those elements are present in middle. No, if you go to the series, those elements are present in middle of this. The elements which is present in middle having more number of oxidation state. For example, manganese. Okay, it has +2, +3, +4, +5, +6, +7. Then element, you just remember like this. The elements which in first part having only few oxidation state, last part also having few oxidation state. For example, best one is for scandium we have +3 only oxidation state. For zinc we have +2 only. Other elements having 2 or 3. If you take copper, cuprous, cupric, iron, ferrous, ferric. So minimum other elements having minimum 2 or 3 oxidation state will be there. But here first elements and last elements having only one oxidation state. Other elements having more than oxidation state. Middle having more number of oxidation state. Okay. This one point you just remember. Okay. Another one is I am telling the middle elements having more number of oxidation state. How we can get this +7 means maximum oxidation state due to sum of electron in s and d orbital. Just remember like this. For example, if you take manganese outright, 25, no? 3d5, 4s2. Add the electron. They are saying add the electrons. So what? S is what? 2. D is what? 5. So we get what? 7. So how we can get maximum oxidation means you add the electron, valence electron you should add, that's all. The valence electron means d orbital 5 electron, s orbital 2 electron. For example, here at the same time we have chromium also +6. Okay, +8 is also there. Some element osmium and ruthenium. Okay, plus osmium and ruthenium having note on +8 is also there. You can lose all the electron. Okay. Okay. Some element in the D block elements, some elements having high oxidation state, some elements having zero oxidation state is also there. Okay. Now, for chromium, 26. Tell me. Start 26. 20. 24. Kata. 24 then. 24. 3d5. 4s1. No. Add the electron I told you, no. 1 plus 5, 6. Okay, just note on this one. It's 1 point. A few points I'll give. In oxidation state, why these elements having variable oxidation state? Why D block elements having variable oxidation state? What's the reason? Same elements getting different oxidation state, no? Okay. What's the reason means? Suppose whenever if you give some energy, the two orbitals have, what's the configuration? I told you, what's the configuration? So the energy, that's the reason, energy of n-1d and ns orbital are same. That note down. Not same, exactly same, nearly same. They put only nearly same. Okay. Suppose if you give or if you apply some energy, the electron is coming from not only n minus d orbitals, it comes from what? Ns orbital. These two orbitals having energy same. Okay. Then only same elements getting 2 or 3 oxygen state, they are saying. Okay. Suppose for example, you know, sodium. What's the oxygen state for sodium? Only one possible. One electron only will come, no? Because of energy. Okay. So for sodium, what's the oxygen state? +1 only. Okay. But in these elements, not like that. Same elements getting different oxygen, more number of oxygen state due to the energy is same. Okay. That's the reason. Energy of n-1d and ns orbitals are nearly same. That's the reason. Okay. Right. Variable oxygen state due to the. Okay. Then what they are saying means here. See, chromium and manganese having more number of highest oxygen state, no? Mostly highest oxygen state. Highest oxidation state, high oxygen state elements can be act as a strong oxidizing agent, no doubt. High oxygen state elements can act as a strong oxidizing agent. Example, you know, potassium dichromate and what? K104, best example. You know, chromium is what? How to find it oxygen state for the chromium and manganese? For 1 potassium, 1, 2 potassium, 2x minus 14 is equal to 0. 1 oxygen minus 2, yeah? Okay, right. So 2x is equal to 12, x equal to what? Plus 6. Remember here 1 plus x minus 8 is equal to 0, x equal to what? Plus 7. Just note down this also. Okay, note down. Highest oxygen state elements can act as a strong oxidation agent. At the same time, it will be some colon character also. Some colon character that also mentioned. Okay. They're all properties, study as it is. Okay. Okay. Then sometimes some elements getting what? Zero oxidation state also. Okay. Nothing but tell your friends, I'll tell your character. Do you know that proverb? Leah? Tell your friends, I'll tell your character. Are you heard about this one? You don't know. Same nickel. What's the oxygen state? If nickel combines with carbonyl ligand, oxygen state is what? 0. Okay. In nickel chloride, tell me. X minus 2 is equal to 0, x equal to what? Plus 2. Are you following? Understood? So, which ligands it is linked? The oxygen state may be 0 or sometimes it has some value. Okay? Then only.
Carbonate ligand alone.
Carbonate. Carbonate is a neutral ligand. Carbonate is a neutral ligand. This is a negative ligand. Okay? So, which ligands it is combining? So, it depends upon the oxygen state increases or decreases, or it may be 0 or some value. Okay? Understood? Right. Understood? Right. So these are the information, just go through. Okay? It's oxygen state, ma. About. Other one is, the next one is, you know, you just remember this one, this is, fifth one is, see, just one important point, that is, you know, say mostly these metals are, it acts as a strong reducing agent, most of the metals, based upon the electrode potential value. See, strong reducing, any element or any metal act as a strong reducing agent means
gains electrons.
Most negative E naught value. What's the meaning for this? Electrode potential will be there. Each and every elements we have some electrode potential whenever it is dipped in one solution. Okay. Suppose the metal getting large negative means what? Minus 3.0, minus 4.0. So that will be act as a strong reducing agent. Strong reducing agent means what? Ready to lose electron. Understood? Readily lose electron. Readily lose electron means what? Easily oxidized. You just note on all of you. Easily oxidized. Okay. This is statement. Then strong oxidation agent means what? The value will be what? From the value only we can decide. They will give two equations. One is negative value, one is positive value. Negative value means strong oxidation agent. Positive value means what? Negative value means strong reducing agent. Positive value means what? Strong oxidation agent. Okay. So based on electrode potential, we can say whether it is oxidation agent or reducing agent. Okay. So the series, metallic reactivity series we studied lower classes. Who is highly reactive? Potassium, sodium, calcium, magnesium, aluminium. Call me na Al will come here. These are highly reactive metal. After that, who will come? Zinc, iron, lead, then copper. It goes on. Copper, silver, gold. Up to this is called medium reactive metal. Highly reactive metal, medium reactive metal, less reactive metal. Okay. So this due to reactivity, we can say this one. But here, how will we say means depends upon the electrode potential. If electrode potential is more negative means we can consider a strong reducing agent. Okay. It's a positive, just right opposite. Okay. Go on. No.
Gains electrons.
Readily lose electron. Ready to gain electron. Okay. Easily oxidized. It will be easily reduced. These are information. Just go through. Then one more thing, that is, for example, just tell me when your textbook is there. For manganese, tell me. Manganese and zinc, tell me. Textbook, the electrode potential value is there. Manganese and, zinc, tell me. Zinc, manganese is what? Off field, cut or not? Off field configuration. Zinc is what? Full filled configuration. Understood? Fully filled configuration. Configuration. You know that. Yeah. Now tell me the value. Manganese. What tableau column is there, no? Tableau column. Electrode potential tableau column. Have you found out? Yeah, not like that. Electrode potential value.
Plus 1.5.
No, electrode potential.
It's given there, sir.
There.
Given in the tableau column.
They are given in other column. Okay, right. Okay. Right. Tell me. Okay, right. Tell me, what is that? For manganese?
Plus 1.57.
Minus, plus 1.57. What? Not plus 1.7. Correct? Okay, zinc. You take the first value. First, we have two values is there. One is called reduction potential, one is called oxidation potential. You see the, one value is given on just top of this. Minus
1.18.
minus 1.18 for zinc. Minus 0.76 voltage. Correct or not? Okay, right. This all is just memorize here. If any element has full field configuration having, which is large negative means what? It's large negative, yeah. This all just memorize. Off field configuration having large negative, both are reducing agent. But off field is strong reducing agent than what? Full field. Okay, from the value only, they will give the value. We have to find out whether it is reducing agent or not. Okay, just so this is what? Both are reducing agent, but this is what? Strong, okay, reducing agent. Just note down, all of you. Somewhat less reducing agent. Okay, from the value only I am deciding. Okay. One more thing you just mentioned, readily lose electron to become, note on, it's very important point, to become stable configuration, Here also, readily to gain electron to become stable configuration. Okay, to become stable configuration, that is also important. See, in our textbook, one question is there. See that. CR2 plus and Mn 3 plus. See that question, tell me. CR, tell me. Okay. CR2 plus is reducing. Okay, right. Then Mn3 plus is oxidizing. Okay, that's the question. Okay. Okay. See, first you write, CR means 20, 24, configuration is what? 3D5, 4s1. CR2 plus means what? 2 plus means what? 1 electron from here, 1 electron from here, it will be what? 3D, 4 configuration. For manganese, 25, 3D5, 4s2, Mn3 plus means what? 2 from here, 1 from here will be lost. So 3D4, 4s0. Okay. So both getting what? Same configuration. Okay. But they are saying this is called reducing, this is called what? Oxidizing. Okay. Reducing means what? See, I told you, reducing means what? Here. Readily lose electron to become stable. Okay. So if you lose 1 electron, what happened? If it lose 1 electron means what? 3D? 3. Are you following? This is oxidizing. So, it gains 1 electron, no? Here minus 1 electron, here what? Plus 1 electron. What happened? It becomes what? 3D5. Okay. See, it gets 3D3 configuration, this is called 3D5 configuration. Okay. So here, who is more stable? 3D5. Understood? Are you following? Okay. So from the configuration stability of the metal can be explained by only the configuration. Full fill is more stable than half fill, other will be partial fill. Okay, understood? Reducing na readily lose electron to become octet. Octet means stable configuration. Oxidation na readily gain electron to become stable configuration. Understood? Okay. So these are the important properties. Okay. Again, we have 5 properties are there. That is only general properties. Okay. This one just memorize ma. It's very important. This one. Okay. Let's go through. They'll give the value. They'll give the two value. Which one is strong oxidation agent? Which one is strong reducing agent? Okay. So more negative means strong reducing agent. Positive means what? Here mostly copper only is having its value will be mostly positive value when compared to other one. So then only copper is considered as a strong oxidation agent. Okay. So from the value only we can decide. Then this also gets go through. Okay. Right. Next one. Other properties are only general properties. Okay. Other properties that is sixth one, magnetic property tell me how to say paramagnetic. How will you say it has what? It has what? Unpaired electrons. Unpaired electron. How to say it is called diamagnetic? Paired electrons, yeah. So all electrons are paired. One more thing is called ferromagnetic. What is called ferromagnetic? This also, here 1 or 2 unpaired electrons means paramagnetic. More number of unpaired electrons. Okay, suppose 5, mostly 5 will be there. Okay, so more number of unpaired electrons. More number of unpaired electrons. Okay. Here, then if you have, the magnetic property can be decided by only the unpaired electrons. Then, magnetic moment also we can find out. No, what's the formula to find out? Magnetic moment. What's the formula? Root of n into n plus 2 bm. Get understood? So, you find out. I'll give on sums, you find out. Calculate number of, calculate magnetic moment of titanium 3 plus. Calculate magnetic moment of titanium 3 plus. Calculate magnetic moment of titanium 3 plus. Titanium atomic number? 22. Correct? 22. So how will you write? 2 na 2. 4s2. Correct? Titanium 3 plus na? Clear? Loss of 3 electron. 2 from here, 1 from here. Understood? So it will be what? 3d1, 4 is 0. So what? N is what? 1 no. Understood? So therefore, what's the formula? Mu s is equal to root of n into n plus 2 root of, correct or not? Okay. Root 3. Root 3. 1.732 Bohr magnetron. Okay, just right. One more thing you find out. You find out yourself. Fe2 plus. Calculate magnetic moment of Fe2 plus. Root 224. How many unpaired turns? 4. You're following? Magnetic moment calculate pannu. Okay. So F is what? 21, 22, 23, 24, 25, 26. Okay. So F is what? 26. 26 means what? 6 na 6. 4 is 2 common. Okay. So Fe2 plus means what? 3d6 only. 3d6 outright. Listen. 3d6 outright. Okay. 1, 2, 3, 4, 5, 6. Understood? Okay. 4. Therefore, n is equal to what? Therefore, n is equal to 4. You substitute here formula. That's all. You will be getting answer. Okay. So magnetic properties. Okay, just note down. Another one is others are fully, fully theoretical part only. So magnetic properties, it forms complex. You know that complex. Why it form complex? What is the reason? Making? Very good. Vacant n-1 d orbital. That's the correct one. Okay. So it's a ligand. It's a metal. Ligand is a ligand donate no. Due to vacant n-1 d orbital. This is the only one reason. Okay. Generally it can accept electron from ligand. Understood? Then small size. This is small size. High charge density. The charge density, positive charge, these are all another reason. Okay, important reason is it has empty orbitals. Generally, it accepts electron from ligand. Okay, that's one reason. Another one is colored ion. No, colored ion. This is also important one. See, how to find out theoretically it is colorless or colored? How to find out? Colored means what? Incompletely filled. Incompletely filled what? D or just note on, all of you note on. Incompletely filled d orbital. Colorless means what? Completely filled. Completely filled what? D orbital. Just note on. Incomplete means what? D. How it will be? D 1 to 9. Correct? Complete means what? Completely filled, or we can say vacant. D10. Just remember. D10. When you write the electron configuration, when it is if it is completely filled means what? We can say colorless. Clear? No unpaired electrons. No. So when you give energy, no chance to excite. Understood? So excitation taking place, then only it is colored. Okay. So here, for example, you tell me Cu plus and Cu2 plus. Tell me which one is colored, which one is colorless. The conditions, this is a condition. Okay. When you write electron configuration, if it is completely filled d orbital means what? Colorless. Incompletely filled d orbital means what? Incompletely filled d orbital. Okay. D orbital means what? Following. Okay. It is colored. That's all. Tell me. Example, copper what? 29. 3D, always 3D10, 4s1. Okay. 1 plus means what? 1 electron will be lost. So what? 3D10. Next one. Here 2 electron will be lost. So what? 3D9. Who is colored? Copper? 2 plus. Who is colored? No. Who is colored? Na? D1 to 9. This is called colored. So what? This is? Color na colorful. Seriya? Okay. Write down. Very important question, very easy also. This is what? Colored. This is what? Colorless. No, no. Okay. Theoretically we can decide, okay, whether it is colored or colorless ion. Okay. You know that? Tell me this one. This one, just find out yourself. Scandium, sorry, Zn 2 plus, okay, scandium 3 plus, titanium 4 plus, just do it yourself. Okay. All are color less. Correct or not? Zn 2 plus then Zn 2 plus na 3d10, 3d10 4s2. 4s2 means what? 2 electron will be 3d10. 2 electron will be lost. Scandium 3 plus na 3d1 4s2. 3 electron will be lost. 0 vacant, no? Titanium 4 plus na 3d2 4s2. 4 electron will be lost. So all are colorless. Just note down. Atomic number, if you are familiar, means nothing this. Okay. Understood? This is the condition one. These conditions only, just remember. You see one examples. Okay. Okay. Right. Understood? Next one, you know that these are all general properties. You study yourself. Alloys, no? What is alloy? Mixture of two metals. Okay. So here we can able to mix the two metals. The tendency the metals having, whenever the two metals mix together, its suppose its atoms and its atoms are interchange its place. That is two metals having same lattice point. That's the reason. Okay. So its metal atoms are interchange its places because the two metal atoms having same size. Then only we can able to mix the two metals to form alloy. Okay. Only one reason, just remember, similar size of the atom. Okay. And then only that can form alloys. Then this metal act as a catalyst, no? All are act as a catalyst, platinum, iron. Platinum is used in asphalt process. Okay. Iron is used as a catalyst in Haber process. Okay. Only one thing you just remember, in case of catalyst, we studied already in chemical kinetics chapter. Catalyst means it increases the speed of reaction only, we know, but it lowers the, just note on all of you, it lowers the activation energy. Okay, it's an important point. It changes its oxidation state during the reaction. Okay. Other properties also there, it will activate the reactant, it will increase the speed of the reaction. Okay. But these two properties very important. Okay. So tired, no?
Exhausted.
They all are exhausted. Okay, this is the first part. Almost I completed. The next part is we have tomorrow. I will give K1 for preparation, KTC R2 in preparation. Then lanthanide actinides only I will say. The second part of the lessons I will teach in the next tomorrow. Okay. Okay, ma. I written everything? All this?
Sir.
Okay, right. Okay, ma.